Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a Hexic equation with complex numbers. We have z plus 1 to the 6th power equals 64 times z to the 6th power, and we're going to be solving for z values. Alright, to be able to solve this problem, there's a couple different methods we can use. Let's start with the first one. So for my first method, I want to turn this into a sum or a difference of squares or cubes. What can I do? Since 6 is 2 times 3, we can actually do both. So let's start with z plus 1 to the 6th power. So why don't we just use the formula for difference of two squares? So you can think of this as z plus 1, 6, you can think of it as z plus 1 to the 3rd, to the 2nd, and then the same thing goes for this. So then you can get a difference of two squares. In other words, you're going to get this squared minus 8z cubed squared. I put that on the left hand side, so now we have a 0, and obviously we want to solve it. To be able to solve it as an equation, we need a 0 on one side. Now this is a difference of two squares, so why don't we write it as z plus 1 to the 3rd plus 8z to the 3rd. That will be one of the factors, and the other factor would be z plus 1 to the 3rd minus 8z cubed. And remember, a squared minus b squared can be factored as a plus b times a minus b. That's what we did here, okay? Now, we get a sum of two cubes and the difference of two cubes. Do you remember the formulas? A cubed plus b cubed is equal to a plus b. And then the other is a squared minus ab plus b squared. And if you get a minus sign here, this will be a minus sign and that'll be a plus sign. You get the idea? So now, by that, we can go ahead and write this as z plus 1 plus 2z, because this is 2z to the 3rd. 2z or not 2z? Well, that didn't work out, did it? That would be one of the factors, which is like a plus b. And the other factor, so that would be one of the factors, and the other factor would be z plus 1 squared minus z plus 1 times 2z plus 2z quantity squared. That would definitely be coming from this one, and then let's do this one, and then we'll put it all together after simplifying. But it's going to be very similar. It's going to be like this, and then you're going to have all plus signs. Okay, z plus 1 squared plus z plus 1 times 2z, and then plus 2z quantity squared. Very similar formulas. Okay? Now, if you put these all together, this is what you're going to get. Let's go ahead and simplify each one of these first. So, for example, this one. This one is fairly easy because that'll be 3z plus 1, and this one should be negative z plus 1. Or you can write it as 1 minus z if you want. This one is going to be z squared plus 2z plus 1 minus 2z squared minus 2z plus 4z squared. And this one is going to be something very similar to z squared plus 2z plus 1 plus 2z squared plus 2z plus 4z squared. Let's go ahead and simplify each one of these. We're going to get 3z squared. These are going to cancel out. You're going to end up with plus 1. From here, you're going to get z squared, 2z squared, and 4z squared. That's going to give you 7z squared plus 4z plus 1. So now we have the following. Our expression can be factored completely into 3z plus 1 multiplied by 3z squared plus 1 multiplied by 1 minus z multiplied by 7z squared plus 4z plus 1. How nice, right? And that is equal to 0. Great, we have linears and quadratics, so that's nice. We can go ahead and solve each one. This will give us negative 1/3. This will give us z equals 1. This will give us z squared equals negative 1/3. So you're going to get like plus minus root 3 over 3i. I think when you square that, that should give you negative 1/3, right? And then this is quadratic. Let's go ahead and solve it using the formula. That would be negative b plus minus the square root of b squared minus 4ac, which is 28. That is 12, negative 12. And the square root of 12 is 2 root 3, so that's going to be negative 4 plus minus 2 root 3I divided by 14. And I think we can write it as negative 7 plus minus root 3I all over 7, something like that. So we are getting 1, 2, 3, 4, 5, and 6 solutions. And that's expected, because this is a Hexic equation. There's another name for it, but I like the Hexic better for obvious reasons, right? Great. So let's go ahead and take a look at the second method, because I think the second method is also fun. Maybe it is funner, who knows? You're going to get to decide. So we have z plus 1 to the 6 equals 64 or z to the 6. Great. Now we can go ahead and use the fact that this is 2z to the 6th power. So we have two 6 powers. Can we factor it like that? No, not really. You don't need to. You can do the following. You can divide both sides by this and here. Of course, the equality is not maintained anymore. And then this will become 1 from here. So now you get the following. 2z over z plus 1, because we can just write it as a single quantity with the same power, equals 1. Nice. If you look at it from a complex numbers perspective, because this channel is all about complex numbers. Did I say that at the beginning? Maybe I forgot, who knows. But anyways, if I didn't, then this channel is about complex numbers. And if you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, trigonometry problems, go ahead and check out Cyber Math. That's cyber with an S. Okay? And I have a short channel too. So from a complex number perspective, this means that a number to the 6th power is 1. What does that mean? Well, 1 can be written as a complex number in the polar form. We can write it as e to the power 2 pi n I. So if you raise both sides to the power 1 over 6, in other words, if you take the 6th roots, there will be 6 of them, because n is going to range from 0 to 5, 0 through 5, right? So it's going to look like this. 2 pi n I over 6. And of course, we want to write this in the simplest form, which is e to the power pi n I divided by 3. In other words, when n is equal to 0, this will be 1. When n is equal to 1, this will be e to the power pi I over 3. And that's just cosine pi over 3 plus I sine pi over 3 by Euler's formula. Thank you, Euler. You're just amazing. You're the best. And now we can go ahead and simplify it, because cosine pi over 3, as you know, is 1/2. And this is root 3 over 2i. But notice that this is not the value of z. This is 2z over z plus 1. So how do you find z from here? Good question. If you call this w, okay, then you can actually find z in terms of w. How? Well, 2z over z plus 1 is w. It's going to give you an equation. You can go ahead and try to solve for z. Cross multiply, put the z's together. I don't know if this is the best way to do it, probably. And then factor out a z, you get 2 minus w equals w. In other words, you're kind of inverting this function. If you look at it as a function, there's so many different perspectives you can use, but that's basically z in terms of w, if we set this to w. Make sense? So now once we find the value of w, this is w, right? We can plug it in to find z. For example, if w is equal to 1/2 plus root 3 over 2i, then z would be w, which is this, divided by 2 minus that, right? And what can I do with that? Simplify this. That'll be 1/2 plus root 3 over 2i. And then at the bottom, we're going to get 3 over 2 minus root 3 over 2i. By the way, this is also some type of special equation, which you can simplify using polar form, but that's not necessary. All you have to do is multiply by the conjugates, or you can actually simplify by 2 first, like multiply the top and the bottom by 2. So that'll simplify a little bit. And then you can go ahead and multiply by the conjugates, like this, right? And then distribute, and let's see what happens. At least we're going to have one z value. That's going to be a 3 plus root 3i plus 3 root 3i plus 3i squared, which is a minus 3. They're going to cancel out. And this will be from sum of two squares, 9 plus 3, which is 12. So that'll be 4 root 3I over 12, which is root 3I over 3. Make sense? Okay, great. That's just one of the values. And did we find it before? We should have. If you look at the first method, yes, absolutely, that is one of the solutions. Of course, there's another one too, but you get the idea. I'm not going to go through all these different ones because it's pretty much the same thing, and you can definitely do it. But I would recommend that you use this formula so that you can directly find, I meant this one, so you can find the z values from the w values directly. Okay, and this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.